So this is Jeff Hamrick at Rhodes College talking for a few minutes about using sampling with replacement to build a confidence interval, an empirical confidence interval, for the difference in two means. So what we have here is some data from our French psychologist. Recall that he gave out a questionnaire to some participants, namely 21 participants in a study, with a variety of questions about volunteerism and charitable work. 19 other participants in the study did not receive this questionnaire. What all of the participants in the study received after a period of time was a second questionnaire, a second survey, in which they were asked whether or not they might be interested in participating in a particular volunteer project. And as you can see from this 2x2 frequency table, there seems to be a connection between whether or not somebody is sort of suggestively prepared ahead of time with a questionnaire and whether or not they ultimately agree to, or at least express some level of interest in participating in a volunteer project. So 11 out of the 21 participants who were given the initial preparatory questionnaire expressed some interest in participating in that project. That's 52%. 4 out of the 19 participants who were not given that preparatory questionnaire expressed an interest in volunteering. That difference is about 31%. But of course, that 31% difference is subject to experimental variation, and what we would like to use is sampling with replacement to model that experimental variation. So here's how we proceed. Just like when we were constructing a confidence interval for the difference in two means, we need to construct two more attributes. I'm going to call these attributes the yays and the nays. The column for the yays is to represent those individuals given the questionnaire. Nays is going to be a column to represent those individuals not given the questionnaire. And I'm going to create the following formula. If the questionnaire given attribute is equal to yes, then I'm going to take the dichotomous response variable, namely whether or not they were interested in the project. If the questionnaire given state is not yes, I'm going to put in a blank string. Okay? So all that does is lift the results from this column over to this column in the case that the questionnaire given attribute is equal to yes. All right? So what I'm going to do here for the nays attribute column is I'm going to create a formula if questionnaire given is equal to no, then return interest in project. Otherwise, return a blank string. And all that's going to do is move this second attribute column over to the fourth column if the questionnaire given attribute column is equal to no. Okay? Now I'm going to define a measure of interest. That measure is going to be a difference in proportions. I'm going to define it on the box associated with the original set of data. I'll call it difference, and here's the formula we're going to use. I'm going to take the count of the yays, that is those individuals given the questionnaire, who then went on to express some interest in the volunteer project, divided by the count of all of the individuals given the questionnaire initially. I'm going to subtract from this the exact same thing, changing the attribute name from yays to nays. Okay. And what we get here is the same difference in proportion that I put in this text box right here. And so that's the fixed measure of interest for this particular confidence interval. It's a confidence interval on the difference in two proportions. So what are we going to do now? We're going to sample with replacement. With replacement, turn the animation off. I'll replace existing cases. I want to sample a number of cases equal to the number of subjects in the original experiment. That's 40. Okay? And notice that this box inherited the measure defined on the original box associated with the set of data. So now what I can do is collect measures. I'm going to go on ahead and finish this screencast up. We'll analyze the results in a minute. I'm going to collect a large number of measures in this case because the data set is small. I can go on ahead and collect, let's say, 3,000 measures. So I'll be back with you in just a second, and we'll analyze the results of this randomization procedure to obtain a confidence interval.